Welcome to the lecture on problem solving on alternatives comparison and project balance. So, in this lecture we are going to deal with some problems based on these topics which we have covered in this week, and we will come to straightway to the problems of different type. So, first of all we will deal with question number 1, and in question number 1 we are basically to find the net cash flow representing the following investment by an investor and finding present worth of net cash flow. So, actually the transaction histories are given at the end of different years, and you have to find the present worth of net cash flow, and you are given two interest rates at 0% and at 12%. So, this kind of problems are very much common, and what we see that we have the data given, and the data is like this, that you have end of year is here. So, it will be moving from you have 0, 1, 2, 3, 4 and 5. Then you have the disbursement. So, disbursement, and then you have receipt. So, in the end of 0, the disbursement is basically 3 lakh, and the receipt is certainly 0. So, there is disbursement of 3 lakh. In the year end of 1, you have disbursement of 75,000, and you have the receipt of 20,000. Similarly, you have in the end of year 2, disbursement is 25,000, receipt is 60,000. Then you have disbursement of 30,000 in year 3, and here you have 135,000. Then here you have 0 and 0, and this is 180,000 and 210,000. So, this is the cash flow which is given to you. You have to find the present worth of net cash flow at two interests at 0% and at 12%. So, you have to calculate it. Now, what we see that when you have 0% interest rate, then the time value of money is not coming into picture, and in that case when you have to find the present worth, so all these things will be simply added up. So, you have to take all the disbursement into account, and you have to take all the receipt into account, and then accordingly you will have to find the present worth value. So, for 0%, if you have to calculate, then you have the disbursement values are all negative. So, you will be adding all these negative values, 3 lakh plus 75,000 plus 25,000 plus 30,000, and then you have positive of, so receipt, and receipt is 20,000 plus 60,000 and plus 135,000 plus 180,000 and then plus 210,000. So, this is your receipt, and if you add them, so you are seeing that this is 4 lakh 30,000 here, and this is coming out to be 2 lakh 10,000 plus 180 390 plus 135 525, and then this is this is 80. So, this is 6 lakh 5,000. So, basically if you see that if you take its summation, it is coming out to be 175,000. So, this is your net present worth value of this cash flow if the interest rate is taken as 0%. Now, if you take a interest rate of as it is shown to be 12%. Now, for 12% what will be the net present worth? So, what you will do is that now at this point of time your and also again you can find this value also like 3 lakh plus, so it will be minus 3 lakh, then it will be again here it will be net disbursement. So, minus 3 lakh, and so it can further be calculated, or you can have alternate methods like minus 3 lakh, and then you have here minus 55,000. Then here onwards you will go to plus 35,000, then here it will go to 1,05,000, then 180,000, and then to 10,000. So, it will give you the same thing from here, it will be giving you the same thing. So, that way you can find for 0%. Now, when your interest rate is in picture, then you have to take into account that value. So, time value of money will be coming into picture. Now, what you see that the present worth value will be, so this minus 3 lakh is anyway you have this is at present time. So, its value is same. Then you are coming to the end of year 1. Now, end of year 1 you have net disbursement here, and that is 75,000 minus 20,000, that is your 55,000. So, it will be minus of 55,000, and if you are trying to say its equivalent value at present time, then you have to multiply it with a factor p by f I n, and that is 1 by 1 plus I raised to the power n. So, n is being 1, so it is 1 by 1 plus I is 0.12. So, you are going to divide it by 1.12. Then coming to the next, now here you have net receipt. So, you have 25,000 and here it is 60,000. So, ultimately altogether you have net receipt of 35,000. So, this will be plus 35,000, and now this has if you have to map it to the present time, then you will have 1 by 1 plus I raised to the power n, so 2. So, it will be 1.12 raised to the power 2. Then you have here again net receipt of 1,05,000. So, it will be 1,05,000 divided by 1.12 raised to the power 3. Then you can further come to the value of 1,80,000, and that will be divided by 1.12 raised to the power 4, and then 2,10,000 divided by 1.12 raised to the power 5. So, that is how you can calculate these present worth values, and if you compute these values. So, this value will come out to be about 49,107. So, this will be coming out to be 27,901. So, that way you can do the basically computation, and you can get the value of this net present worth, and if you calculate that, it will be coming out to be something close to minus 12,915. So, what you see that as the interest rate is basically increasing, as the interest rate is changing, then what you see that this present worth value is changing. Now, you can have a look at how there was a receipt. Now, in this case you have receipt, although you have receipt of larger values at the later time, but its value at present time becomes very low. So, that is why altogether you have net disbursement value, you are completely net value is in a negative value, and that is because of these values. So, but had these transactions been at the at the top at the initial periods, this situation would have been different, because its contribution will be more at this point, because this is at a future time. So, that is how you find these cash flow patterns you analyze, and you find these present worth values. So, next we are going to discuss the question number 2. Now, in question number 2, basically we have to find the ratios. So, to determine ratios, and the ratios we have to, so we have basically two investment opportunities, ratios for two investment opportunities, A1 and A2, and the ratios what we are to calculate. So, these ratios are like present worth A1 upon present worth A2, and annual equivalent A1 to annual equivalent A2, and then future worth A1 to future worth A2. So, you have two opportunities, two investment opportunities A1 and A2, and the cash flows are provided, and the receipt and disbursements are provided, and you have to find these ratios for the interest rates given. So, first of all you will have the alternatives. So, if you take the alternative, so you will have alternative given, and so this we can write here. You have alternative A1 and A2, and then you have the end of year. So, you have end of year, and end of year will be 0, 1, 2, 3. So, this is your end of year, and for alternative A1 this is coming to be minus of 1000, and this is for 1 it is 1, 2 and 3. So, for 1 it is 1100, this is 1210, and this is 1130, and for A2 it is minus 1200, this is 1100, 1210 and 1330. Now, what you see that in this case you have to find basically the the ratios of these PW1, PW2, then you have AE1 and AE2, then you have future worth A1 and future worth A2. All these ratios are to be calculated, and for that you are given two interest rate values. Interest rate values are 0% and 10%. So, for 0% and 10% you have to find these ratios. Now, when you have the 0%, as we know that in the case of 0%, you can see that the present worth value will be same. So, you have to add them. So, at 0%, now if you look at for A1, so PW for A1 will be minus 1000 plus 1100 plus 1210 plus 1130, and PW A2 will be minus 1200 plus 1100 plus 1210 plus 1330. Now, what you see is that here it is minus 200 more, and in this case here it is plus 200 more. So, altogether their sum is same. So, basically PWA1 upon PWA2 it will be same. So, it will be 1. So, for 0% interest, when there is no interest rate provided, in that case there is no matter, PWA1 by PWA2 will be 1. Now, we know that if you calculate AEA1 and AEA2 or FWA1 and FWA2, these ratios are same, as we have understood the principles of economic equivalence. So, all these ratios become same, we can calculate it, and then in all these cases these values will come out to be 1 itself. Now, if you take the interest rate of 10%, in that case how to find these present worth values ratios. So, if you take the at 10% interest, now this ratio PWA1 upon PWA2. Now, this will be basically, so you will have in the first case you have minus 1000. So, it will be minus of 1000 plus, now in this case you have 1100, 1210 and 1130. So, this 1100 its present worth, for that we will have to divide it with the 1 plus I. So, it will be divided with 1.1. Then you have 1210, it will be divided with 1.1 square, and the next is 1130, it will be divided with 1.1 raised to power 3. Then you have to divide it with the 2. So, in that first was 1210, 1200, then we have 1100 by 1.1 plus again 1210 divided by 1.1 square, and then here you had a 1330 divided by 1.1 cube. So, that way you have these PWA1 and PWA2 can be calculated, and if you compute, this will be minus 1000 and this will be also 1000. So, and this will be also 1000, and then it will be 849. So, minus of 1000. So, it will be plus 1000 plus 1000 and plus 849, and then divided by, it will be minus 1200 plus 1000 plus 1000, and then again it will be 1000. So, that way you will have the values. So, in this case here the value will be this 1000 will cut. So, it will be 1849, and in this case you will have 3000 minus 1200. So, it will be 1800. So, this way 1.027 something like this ratio will be coming as the ratio of these net present worth values for the different interest rates. So, that is how we calculate the ratio. Now, if you, so this ratio will be same. So, your annual equivalent also for A1 to annual equivalent A2 will also be same as the future worth A1, then future worth A2, that can be computed basically, and that will be PWA1 divided by PWA2, and that can be equal to 1.027. So, this way you can calculate these net present worth values and find its the ratios for the two types of basically the for two types of investments. You can calculate what will be the value of the ratios of this PWA1 and PWA2, similarly to A1 to AEA2 and all that. Now, next we are going to discuss about a problem which we are discussing in the last lecture we could not complete. So, it was related to the project balance, and as we discussed that in the case of project balance you may have the different types of cash flows, and you need to know the value of n prime, that is your discounted payback period, and how that is going to change if the transactions are changing. So, that is to be seen in this example. So, what we have seen that we saw that in that case you had four types of cash flows, and as you know that you have minus 1000 and 1, 2, 3 and 4. So, in the first case we had computed, it was 912, then you had 684, then you had 456, and then you had 228. So, that was your first case of the cash flow 1. Then and for that we had computed the project balance at all the different times, and we saw that it was minus 1000 at 0 time, and then we computed for this. So, we found the project balance to be we found the project balance going like this. So, at 0 time it was minus 1000, and then it went to at 1 year time it was minus 338, then so it was 1, then at 2 it went to 261, so it was 261, then at 3 it went to 783, and then further finally, so it was 3, and then in the fourth one it was 1200. So, that was so in third and fourth we could not we had not calculated at that point of time, but it can be computed and it can be seen that it will be minus 1000, and you know that the interest rate is basically, so it will be question 3, and here I is 25%. Now, if you look at, so what we saw that here n prime was coming out to be 2. Now, let us again further discuss that we have to discuss about 4 types of cash flows diagrams, and we have to find this project balance for these 4 types of cash flows. So, this is cash flow 1. Now, the second type of cash flow we will talk about basically this is your minus of 1000, and then you have the 1, 2, 3 and 4, and this is all is 631. Now, in this case when we talk about finding the project balance values, so you have minus 1000. So, at 0 time, now for 2 if you look at, so for 2 you can calculate the for 2 at t equal to 0, the project balance at 25% with 0 time, it will be minus 1000. So, that is obvious. So, when we try to draw this project balance diagram, it will be minus of 1000. Then if you go to the first time equal to time at t equal to 1, now in this case it will be minus of 1000, and it will be multiplied with 1.25 and then added 631. So, it will be 1250 plus 631. So, it will be minus of 619. Then at t equal to 2, it will be project balance will be computed. So, it will be PB 25 1. So, PB 25 2 will be minus 609 into 1.25 and then plus 631. So, 619 and multiplied by 1.25. So, it will be something like 773 or so, and 773. So, it will be minus of 773 plus 631. So, it will be minus of 142. So, you are getting now what we saw that in the earlier case at n equal to 2 itself, at t equal to 2, you got the direction changed, the sign changed from negative to positive, but here still it is negative, and that is basically because of the difference of the initial transactions. You see, in the first year you had the larger amount of transaction receipt 912, whereas you have here only 631. So, that has created the difference here. Now, go to at t equal to 3. At t equal to 3, if you compute PB 25 at 3. So, it will be again minus 142 and multiplied by 1.25 plus 631. So, 631 will be further added. Now, minus 142 plus 631 you can write. So, now it minus of 142 into 1.25, it will be something like 177.5 plus 631. So, that will be basically coming out to be 452. So, that is how you can calculate that, and then at t equal to 4. So, this PB 25 4 will be again 452 multiplied by 1.25, and then you have plus 631. So, it will be 565 plus 631, it is close to 1200. So, that way what you see is that in this case, in the case of 2, this n prime has come out to be 3 years. Now, you can further check for the next type of cash flow 3. Now, in the cash flow 3, we had seen that you had minus 1000 here at 0 time, and you have 4 years, and in that you have 284, then you have 568, then 852, and then you had this 1136. So, as you see here that you have small amounts receipt in the initial times, and how it will be going to affect this project balance, let us see that. Now, in this case again PB 25 0 will be minus 1000, then PB 25 1 will be minus 1000 into 1.25 and then plus 284. So, it will be minus of 1250 plus 284. So, it will be 966, but with negative sign. Similarly, you go to PB 25 2. So, it will be minus of 966 multiplied by 1.25 plus, now you in the second year you have the receipt of 568. So, minus of 966 multiplied by 1.25, it will be something like 1206 or so. So, once you do that, once you do its arithmetic computation, you are coming out to be 640. So, it will be 1208 or so, and then that multiplied by that plus 568. So, it will be 640. Then you come to PB 25 at time 3. So, it will be again negative sign. Then you come to 3. So, again it will be minus 640 into 1.25 plus now you have 852. So, with 852 now 640 multiplied by 1.25, that will give you 800 plus 852. So, it will be giving you minus of, so it will be giving you 52. So, it has basically gone to positive sign, and that is why n prime has come out to be 3. If you compute for fourth year, so for fourth year 52 multiplied by 1.25 and plus 800, so this will be 1136, and then again this is 65, so it is coming out to be close to 1200. So, project balance in the net value is coming out to be the same one like 1200 at the end, but the n prime is coming out again here as 3. Now, in the end for the cash flow 4, now cash flow 4 was like you have 1000 here, and in the end of fourth year you had the 3641. So, for this what you see is that for certainly with this at 0 you have minus 1000, then at 1, because there is no receipt or disbursement. So, at 1 it will be minus 1000 into plus into 1.25. So, this will be plus 0. So, minus 1250. Then you go to the second time. Now, in this case you have again 1250 multiplied by 1.25. So, it will be minus of 1563, and in the case of third it will be minus of 1563 multiplied by 1.25. So, it will be 1953. So, it will be basically this 1563 multiplied by again 1.25. Then once you go to 4, then in that case you will have so it will be minus of 1953 multiplied by 1.25, and then you have added to 3641. So, if you look at this, it will be into 5 upon 4. So, minus 1953 into 5. So, it will be 9765 divided by 4 and plus 3641. So, it will be 2441, it will be minus and plus 3641. So, what you see is that you are getting as 1200. So, in all these cases what you see that ultimately and the end you have 1200 as coming as the project balance at the end of 4 year, but what you see here that in this case your n prime comes out to be 4. So, n prime basically is going to change. In this case, in the last two cases it was in the first case it was 2 years, second and third case it was 3 years, and the fourth case it was 4 years because of this typical type of cash flow transaction. So, that is how the meaning of cash flow meaning of project balance is you can find at what time there will be a situation of signing that present to net value from changing from the loss to profit, and so, and that can be computed, and that is being utilized for these investment purposes. Thank you very much.